Hi, welcome back to our new session. Right, last time we are in the new chapter, new section, which is sketch the graph. Which we have seen one example that thing was wrap up everything. Right, the increase-decrease interval with the relative extrema. Also, the concavity intervals with the point of inflection, right, together with the domain that, and of course the intercepts and the asymptotes, together we are able to draw a accurate graph, right, of the function, right, which is relatively more accurate than what we have seen in our precalculus, right. That was the thing we have seen. Right, then we move on to the other question. Sketch the curve that f of x equals x squared minus 2x plus 4 over x minus 2. Right, to sketch that. So first of all, it's clear to see that, well, the domain will be denominator not equal 0. Whatever, if it's a vertical asymptote or no, it depends on the thing later, right? But first of all, right, it's domain from negative infinity to 2, union 2 to infinity. Right? Everything we can take, but we cannot take 2. Right, so as last time, right, we just give a result fully on the left side and we do calculation more on the right side. Right, therefore, since I don't have enough space here, right, for the limitation of the space, it usually should be all the way down that we just get what to do and put the result underneath and so on, so on, so on, but we don't have that much space. Right. So the next thing, right, after domain will be xy intercept. So for x-intercept, let f of x equal to 0. That when the function equal to 0, if we write the full step, that we need to then let the whole thing equal to 0. If we let the whole thing equal to 0, which is a rational function, that the numerator need to be this 0. But we see that, well, this one cannot be factored. Also, when we try to use the formulas, right, negative b plus minus square root of b squared minus 4ac, we will get over 2a, right? We will get a complex number, an imaginary number underneath, which is a negative number underneath our radical sign, but imaginary number over r, that's 4 minus 16, which is a negative 12. Right, it's not real anyway. Right, our function was defined from real number to real number, at least. Right, the subdomain of the real number, at least it has to be real. But we have the we have the complex number over here that we have no solution in that case. And the y-intercept, to be clear, that's just f of 0. Right, we substitute 0 in there, 0 squared minus 2 times 0 plus 4 over 0 minus 2. That is 4 over negative 2, which is negative 2. Right, so we have the y-intercept is the point 0, negative 2. Right, so we seal the conclusion. No x-intercept. Y-intercept is 0, negative 2. Right? That is what we have for the intercepts. Then after the intercept, what we need are the asymptotes. Right? F of x cannot be factored, cannot be simplified. That we get just the denominator equal to 0 is our vertical intercept. And since the power is one power higher, so we don't have horizontal intercept. But when we do the division of the numerator divided by denominator, we could do long division or synthetic division to simplify it. Right? Once it's 1 degree higher than the denominator of the numerator, we could do the division. Right? Synthetic division, if you remember, right? Just get the fraction of what we have, and solve for the denominator or divisor to get the number supposed to be on the side. And then we just carry down, multiply, add, multiply, and see what remains. Right, so f of x could be written as x plus 4 of x minus 2. And as x goes to infinity, this part goes to 0. Then it will be infinity, but the line yields to x. And negative infinity, similar way, this bottom will be 0, and it will be yields to negative infinity as well. Right, so we have the slant asymptote is y equals x. Well, when x goes to infinity, this portion will be yields to 0, but x is still x. So it goes to infinity, of course, but in the view of the graph, right, we have the function will approach us to x as the function, as the asymptotes. Right, so we have vertical asymptotes, that is x equal 2, and we have slant asymptote, that is y equals x. It is slant asymptote. Right? It's not like the horizontal, but it's slant asymptote. Right, so that's our asymptotes. Then finding out the increasing, decreasing interval and the relative extrema, we need to find out what is the first derivative. Right, so take the f prime of x. If you want, you could use the quotient rule. Right? You don't have to show it, but if you want, you could say u is x squared minus 2x plus 4, v is x minus 2, u prime is 2x minus 2, v prime is 1. Right? That's our typically the quotient rule. Last time we didn't show because, but well, you could show that, right, if you want to make sure what we are doing. Quotient rule, that's denominator square u prime times v minus v prime times u. Then we simply multiply it out, that we get, well, 2x squared minus, minus what? Minus 6x plus 4. Minus x squared plus 2x minus 4. That we get our f prime, we could subtract it. Right, that is x squared minus 4x which could be factored as x times x minus 4 over x minus 2 squared. Right, so we could keep the result of f prime on the side, f prime x equal x squared minus 4x over x minus 2 squared, which is factor it, is also fine. Right, to save it on the side. I don't have enough space, so erase that. And we have f prime of x to be that. Well, if you want, then you could explain that carefully or clearly that the f prime is undefined only at x equal 2, but not in our domain. You could write one more sentence. F prime x undefined at only x equal 2, but 2 is not part of our domain. Therefore, we don't need to care about undefined parts later, right? Then finding critical numbers, just solve for f prime of x equal to 0. That the whole equation equal to 0 is what we need to do. And what we have is the only numerator. Right? For a rational function, the numerator equal to 0, that's good enough. And we get x equals 0 and x equals 4. Well, we have f of 0 is negative 2 evaluated already. F of 4, that is 4 squared minus 2 times 4. Over 4 minus 2. That is 16 plus 4, 20 minus 8 is 12 over 2, which is 6. Right, so we have 2.0 negative 2 and 4, 6. So erase that. We have 0, negative 2 and 4, 6. Right, 0, negative 2 and 4, 6 are the points. Right. So we have 0 and 4 to be critical number. Therefore, we need to break our intervals, right, from negative infinity to negative to 0. Right, the first critical number, cutting the domain, right, 0 to 2, and 2 to 4, then 4 to infinity. Test value, you can put anything. The denominator, we observed f prime is always positive. The only difference is the numerator. Okay, right? So the sign of f prime of x and the shape of f of x. Right, we could input any value we want for the test value, as long as it's in the interval. Negative 1, 1, from 2 to 4, 3 is the better one, from 4 to infinity, 5 could be a good one. We see that f prime of x, that is x times x minus 4, divided by a positive number, whatever it is, right? As long as it's not 2, it has to be positive. Right, so when we input negative 1, we get negative number multiplied by negative 1 times plus minus 4 is another negative, over positive, that is positive. For 1, it's similar, we get a positive number, 1 minus 4 is negative, divided by a positive number, that's negative. But from 2 to 4, we get a positive number multiplied by a negative number, then divided by positive, we get 3 in there, right? 3, we get a negative number, right? And from 4 to infinity, we get five input, right? Both of the numerators are positive, then divided by positive, that will be positive. Well, of course, if you know how to solve the polynomial inequality, when you see the x times x minus 4, you can just solve for the interval to see which one is positive, which one is negative. Then, of course, we have f of x, positive, that we have increase, negative, decrease, decrease, and increase. Right, so we have our relative maximum is the point 0, negative 2, and relative minimum from decrease to increase at 4 is 4, negative 6. Right, the point. And then the increase-decrease interval is showed by the picture over there. Right, so we have from negative infinity to 0, from 0 to 2, to the 4, and 4 to infinity, that's different pieces are increase, decrease, and also decrease, increase. 0, negative 2 is our relative maximum, and the 4, negative 6 is our relative minimum. Right, so the table of first derivative with the increasing, decreasing interval are clear, and the points are also fine. Right, if you want to say the point 0, negative 2, the point 4, 6, right, to be the relative maximum and relative minimum, you're also fine. Then the interval is not necessary to explain that, you just write out the graph or the table, that will be good enough. Right, that's the increase-decrease interval. Then to find the f prime, f double prime, that is, well, u is x squared minus 4x, v is x minus 2 to the second power, u prime is 2x minus 4, v prime is 2 of x minus 2. Right, that's our u prime and v prime. Right, then the second derivative, well, it's v to the fourth, no, not v to the fourth, it's x minus 2 to the fourth, v squared, u prime times v, this guy get a little bit nicer, u prime times v minus v prime times u. Right? Well, we see that, well, x minus 2 is the common factor that can be factored out to be once, third time, and cancel out. simultaneously the numerator, every term, and denominator, that we get is x minus 2 to the third, 2x minus 4, x minus 2, minus twice of x squared minus 4x. By that we get 2x squared minus 4x minus 4x, that's minus 8x plus 8, minus 2x squared plus 8x, which 2x squared cancelled, negative 8x cancelled with 8x. By that finally we get 8 over x minus 2 to the third. F double prime, that's 8 over x minus 2 to the third. Right, for that one, well, to find possible point of inflection, here's f double prime of x equal to 0, that's full step, nothing shortcut. F double prime undefined. Undefined as the denominator equal to 0, but it's not part of our domain. To be nicely notation, that is belongs to, and we put a cross there, that means not belongs to our domain. Right, for f double prime equal to 0, the rational fraction, it has to be 0, no solution. So find out, well, we don't have any point of inflection. So naturally the concavity may be changed along the domain. Right, so we break them. Naturally changed by the domain, so we break that from negative infinity to 2 and 2 to infinity. Right, for the test value, for the value of double prime, and for the shape of f of x. Well, when we consider that f double prime of x is a positive number divided by something we don't know, right? It is positive, then the ratio of sign, the sign of this ratio only depends on the denominator. Right, so if we put a 0 here, if we put a 3 here, right, that's denominator for 0, that's 8 over 0 minus 2 is negative 2, to the third power is a negative 1, which in total that's negative. And for the 3, oppositely, that is a positive number divided by a positive number, which is positive. Therefore, we get a concave down and a concave up. From negative infinity to 2 to infinity, that's concave down and concave up. We don't have the point of inflection. Right, so finally, we just wrap up together, right? The increasing decreasing interval we have the concave up, concave down interval, we have the extrema, we have the point of inflection, we have the intercept, we have the asymptotes. Right, together we just wrap up two pictures together from negative infinity to 2 to 0. 0 to 2, 2 to 4, 4 to infinity. For the increasing decreasing part, that we have increase, decrease, decrease, increase. For our second derivative, we have all the way before before positive 2 is concave down, afterwards is concave up. And finally, for the shape of the function, we have increase and concave down, decrease and concave down, then we have decrease and concave up, and increase and concave up. Right, that's our picture. That's our table. So to draw the picture, right, we have from all the points, we have 0, 4, negative 2, 2, and no point of inflection. So we have 1, 2, 3, 4. Whatever it is, negative 1, 2, 3, 4, 5, 6. And 0 is at negative 2. And 1, 1, negative 1, 1, 2, 3, 4, 5, 6. Right, so a couple special points. We have the y-intercept is at 0, negative 2. We have the vertical asymptote. Vertical asymptote at x equals 2. Maybe to put it on the left side. Right, and the slant asymptote at y equals x. Slant asymptote at y equals x. And the line. What else we have? We have 0, negative 2, that's our y-intercept. And so we have 4, 6, 4, 6 to be our relative minimum, and 0, negative 2 is also the relative maximum, and so on. And the table, we should have it already. I just erase a little part, since we're pretty sure that it will go up to that. So for that piece, we have increased concave down, decreased concave down, decreased concave up, and increased concave up for that. We looks like we need more spaces. Then to draw that, well, we have the first piece all the way to 0 is increased concave up, and we have the slant asymptote, so go yield the asymptote but not touch that. And on the right side we have the vertical asymptote, right, but it's decrease and concave down. Right, so we yield to the asymptotes of that. And from the right we have minimum, relative minimum at 4, negative, 4, 6. That point is from 2 to 4 is decrease and concave up. Decrease concave up to the minimum, and then increase and concave up. We get a slant asymptote. Right, so that vertical asymptote and so on. Then at the end, finally, we have our range. We could put it, it's from negative infinity to take the negative 2 is okay. We're able to take negative 2 as the value. And union the 6 to infinity. Right, so this is our full step of how to do this question. Right, how to sketch it. We have everything: domain, intercepts, asymptotes, increase decrease interval, concave up, concave down interval with the relative extrema, and with the point of inflection at the end. Just wrap up the characteristic of each small pieces together, that the interval will be cutted based on the smallest piece, from 0 to 2 to the negative infinity to 0, 0 to 2 to the 4, 4 to infinity. All 4 pieces together, we get the piece of this kind of graph. I find everything together. So that is the first question we'll see.